Hi, it's Gadget UK here again, back for the second part of the exciting Nomad repair here. This was sent to me by a friend, Dennis Vandenbroek. I'll post some links to his YouTube channel, his Twitter. He's a really nice guy. I still can't believe he sent this to me. This is just amazing. It's like my birthday and Christmas all come at once. I've been so excited. As soon as this arrived, within 20 minutes I had the board out and I was soldering capacitors on and working my way through part one there. I just couldn't wait to get on with this. And I think you'll agree, this is looking pretty tidy. I'll give you some close-ups in a minute, but I mean, there's still capacitors on here that I will swap out, but you know what? I think I'm going to do that in a second part. We'll do that as a let's recap a Nomad kind of thing, and I'll go through and we'll replace them, you know, the ones that haven't been replaced, which is the majority of them, to be fair. If you look at all the ones with the red, that's red, that's not. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and there's 4 on the main board. So yeah, about 21 or 22 capacitors at least need swapping out still. The ones that are left on here haven't leaked. They don't look like they've leaked, but I wouldn't want to leave them there. I don't think anybody would really. It's nice sometimes just to get these things up and running by, you know, fixing the things that need attention, you know, the ones that have leaked. But if I left it 6 months or 12 months, the other ones might leak. So it would be a good idea to replace them all, because they're all the same brand. And if you're going to spend a huge amount of time replacing some of the caps, you may as well do them all, really, and give yourself some confidence it's going to be alright in the future. So in the previous video, you could see we powered it here from the board because the regulator has, you know, that was incinerated in this point down here. So the next step is to try and reverse engineer. I'm guessing it's either a transistor, MOSFET transistor, or probably a regulator. I'm not sure. I might speak to Dennis in a bit actually, just to see what he knows, whether he's got a part number or something for that. But I'm thinking if it's a regulator, we can replace it with like one of those recom devices. I think I'm going to order one actually, 5-volt recom, because we know this is now working with just 5 volts, so there are no other voltages needed for this. It's a little bit different actually when you've got the original LCD, because you may find that the 9 or 12 or whatever that comes in here is kind of used somewhere else to step up to a higher voltage for the screen, for the backlight. It does say here warning high voltage. It might just be that, you know, it drops it to 5 and then the 5 is used, you know, to ramp up the voltage somewhere else. I don't know. In any case though, it'd be useful to now trace where that 5 volts, the orange wire there, goes to. I'm guessing it'd be really nice if it went to one of the 3 pins here. If it goes to one of the 3 pins here, that's a safe bet that this is a 5-volt regulator. So back over the other side of the room again. So I've got the meter on continuity here, and as I say, what we're going to do, I'll zoom you in a little bit, and I might need to, I don't know, rotate the board a little bit here. Let's just see if we can rotate this on the map and see if we can give you a slightly better view here. So hopefully you can see the connections up here, and there's barely any copper exposed there. And all I'm going to do, just move the camera down a bit, all I'm going to do is test on continuity from the red wire there, that's 5 volts, to the 3 pins around here, just to see if we end up with a short. So super nice. In fact, I think we have already. Yeah, so there's nothing there. I can't see the other pins, this is the problem. Yeah, you're not going to be able to see this because the traces are gone. I'll try and explain. You have a trace on the left hand side here, and we've got just a little bit of resistance there. So I think that's like an input. The middle one I think is like a ground. That's gone, you know, and the whole pad with it has gone. And then there's one to the right here that came down here, and I think it kind of wrapped up here, and the trace is gone. Where the probe is there, the trace is gone, but it went to this inductor. We've got short. So yeah, this is a 5-volt regulator. So it's simply a case of fitting a regulator somewhere on this board here. We take the first pin there, which is the DC input smoothed by this cap here, into the regulator, you know, so like, I don't know, between 9 and 12 volts-ish roughly, going into the regulator. The ground, well, we've lost the ground here, but we can find, this is all ground here, we can scratch some of that off and use that as ground. And then the output of the regulator, the 5 volts, is just going to go to that inductor, which, if I just test that again, hang on, let me show I've got a good join. Yeah, you can hear we've got a short there. Once I've done that, then it should work with a standard power supply here and the switch, instead of having to use the bench power supply. So we'll perhaps do that a bit later, because it's going to take a number of days for the regulator to arrive. But I think the next thing we'll do is we'll have a go at fitting the screen, I think. So despite what we're saying about recapping the whole thing later, I have recapped this board. It just makes sense because this is the the main board. We've got the main ASIC here. We've got the 68,000. You want good smoothing on this board at the very least, and we don't want you get leakage here. Look at the pitch of the that main chip there. So we don't want to risk any damage to that. So yeah, I've done the 4 capacitors on there, marked those little red dots, just so I know I don't need to revisit this board. I've detached the 2 wires we had on there, and I'll attach those temporarily to here in order just to get the thing up and running. So I can now stick this back into its shell. I'm going to replace the missing screws with the sacrificial Game Gear I've got here actually. It's the one with an absolutely killed board. I'll show you the board in a minute just so you can see. Yeah, this is that Game Gear. You might not be able to see that well, but all the pads here are damaged, and all of the connections that go to and from these pads, there's several of them on, at least on the Z80 and on the RAM here, are bad. So yeah, I mean, you could in theory do it with bodge wires, but I would say there'd be at least 10 or more bodge wires on there, and it's fairly corroded, this, you can see. So yeah, it's just not worth it. There's no screen in this. This needs a new screen as well, and I've got another Game Gear or 2 that I can use for future McWill mods. It's still got a couple of the original caps on here, but nevertheless, yeah, I think we'll just use this as spares. I can use the screws off this to fix this. There you go, full set of screws in there now. That's good. Right, so the next thing I'm going to do is focus on the screen. Now, as things transpire, obviously I went looking out how best to wire this up, and there are a number of guides out there that talk about the inefficiency in feeding 12 volts, the 12 volts that comes in, where's it gone? The 12 volts that comes in, or between 9 and 12 volts I think it is roughly, it might be nearer to 9 with the proper power supply, into this board here. Now you've got a DC to DC converter down here. Now I went away and looked at the data sheet for that, and again then followed on looking at some of the guides where to connect the composite and where to connect the supply rails and things. One of the things that seems to be quite a common mod is to, coming back to the efficiency of this, is instead of feeding that 9 volts, well let's say 9 to 12, because I think it's going to vary a little bit depending on your power supply, between 9 and 12 volts into this PCB, the DC to DC converter drops to 5 volts, and I've checked that, I've looked at the part number, it's the 5 volt variant. You can get a few different versions. There's one that'll do 3.3 volts. Now there may well be a 3.3 volt regulator on here that that comes after that, I don't know, but nevertheless that's the 5 volt version. So it's dropping from 12 volts to 5 volts, and it's done with a DC to DC, so it's a lot more efficient than like a linear regulator. Now the component I've got missing on the system down here, TR201, as far as I can understand, and Dennis actually helped me point this out, I think he said it was like an LM1115 or something, a 5 volt regulator. And I'm looking at that, and it's a surface mount version. You can see the footprint is tiny. It's no wonder that is burnt up. That's going to be a common source of failure on these. If I was going to fit another 5 volt linear regulator on there, I'd use the larger one, the larger package, and maybe scratch off the ground here and mount the ground of the tab there, and then a few wires coming off to fix that. And I have ordered a recom device, another DC to DC converter, as I was going to attempt to fit that first, because that's going to be more efficient than the linear regulator. But then I started thinking, this needs 5 volts, this side here needs 5 volts, so coming out of this regulator here we need 5 volts. So, and obviously if you put the 9 to 12 as an import, it's given us 5 volts, and it's up to 2 amps. And I just got a brainwave. If the Nomad draws, I don't know, let's say less than an amp, and the LCD draws less than an amp off the 5 volt side, a lot less than an amp, because I wouldn't want to go up to 2 amps. It'll provide up to 2 amps, but let's say you can get down to 1.4, 1.5 amps combined for the Nomad and the screen. In theory, I could do a mod with this now. I could take the 12 volts out of the smoothed input here. It's going to be from one of these caps somewhere, probably that one I would think. Well, it might be this one, I'm not sure, but we'll check that in a minute to see where the positive goes in terms of these caps here. And we can take a wire, feed it into the 12 volt side, the 9/12 volt side here, So the DC to DC converter there's got what it needs. It's then going to be providing, well, as long as we've got a ground, it's going to be providing 5 volts out to the LCD. We can then tap off that 5 volts and backfeed it to where the 5 volts would come in from the missing regulator. So in theory, we've got even more efficiency, because this DC to DC converter here is going to be powering the whole lot. It's going to be powering the Nomad and the screen. So in order to do that, I'm going to, you can see I reattached the wires here on this board here. So I've got the +5 going to the inductor there. I have to confirm that's correct. That's where the 5 volts would go. And I've borrowed the ground off the back of the connector there. This better place is perhaps somewhere over here in one of these caps. You would want to take it from the negative of one of these main smoothing caps here somewhere probably. But if I now wire this up to the bench power supply and put my meter in series with the positive connection, put it on the amps, and we'll just measure the current draw. Obviously I have to connect the other module up here, the processor board here with the ribbon. We'll get a cart in there and I'll power it up and we'll just see how much current it's drawing. I'll write that down, and then coming back over to this, as I say, in theory we can do the similar thing here. I can find where the 5 volts is on here. I'll power it with 12 initially, have a measure around, find where the 5 volts is coming out of here. I can look at the data sheet for that and just do some connectivity tests. Attach a wire, so I'll have a ground and a +5 wire for this, and we're bypassing the DC to DC converter at that point. And again, I'll connect it to the bench power supply, the meter in current mode in series with the positive connection, and we'll see how much this screen is drawing in the way of currents. And provided that combined the less than 2 amps, like I said, I'd be happy if it was near to or less than 1.5 in total. That's the way I'm going to go. That's how I'll wire it. We'll have this DC to DC converter powering everything. So I had a bit of a disturbing moment there, where when this board was in its shielding, it worked initially and then suddenly the 5 volt went down to 0, and I think there must have been a short with the shield somewhere, so I need to inspect that to find out what's going on there. But can you hear this? Yeah, you might be able to faintly hear that. If I just turn the volume up a little bit. So you can hear turtles there. So that's working. So I switch the power supply off now. So I'll put the meter in current mode DC, and then typically with these meters you've got to move your normal place there, your normal banana plug to either the 10 amp or the 300 milliamp. Well, it's going to be drawing more than 300 milliamps, so and I think that's fused, the 10 amp is unfused. And if we put this in series now, so I'll show you what I mean. So when the 5 volts is coming in here, all I need to do is put one end on the probe like that, and then put the other end to here. So it's now in series with the connection, so we can measure how much current is going through that positive connection there. Switch it on, and pointing to the back of the meter there, you can see it's 1/4 amp. Super low. That's amazingly low actually. Hang on. Yeah, can you hear the sound? So yeah, 1/4 amp. That's super low. So that's good news. So all I need to do now is work out how much the LCD screen is drawing, and the easy way to do that is to find out where the 5 volts comes out on the DC to DC converter. Attach a wire, and then attach a ground wire, connect it up to the power supply the same way here, and we can measure the current the same way. It won't be being driven, so yeah, there's going to be a difference in how much current's drawing, but it would just be useful to see how much current it is actually drawing in that state. If we're low, I don't know, less than 1/2 amp or 3/4 of an amp, it will be fine, and the LCD screen DC to DC converter will be able to drive the whole lot. So looking at the data sheet here for the XL1509-50, and I've checked it as the 5 volt version we've got here, you can see the output comes on pin 2, and obviously through an inductor that connects back to the feedback, so it's got like a feedback loop there to make sure that it's outputting what it should be outputting. So we can measure anywhere, either pin 3 or pin 2. Pin 2 is the best place to measure that really, although you're going to get the same rate in the, reading there just because of that inductor L1 in the root there. So I'll find pin 2, do some connectivity tests. There's a diode connected to that on this example thing here, and obviously over here might be a good idea where that cap is there, top positive of that cap. and we'll connect the wire up. I'll connect the wire up to the ground. Yeah, you can see the ground rail down here. It's not going to take too much to find the ground. Attach a wire to that, and we'll just do the same thing. We'll just power it with 5 volts initially. Make sure it's not doesn't blow or anything. The backlight of the screen might illuminate at that point, and then I'll put the meter in series with it. You got the notch in this corner, the bottom right corner here. Pin 2's there, and I went around testing these caps on the. That's the negative side. I tested the positive on that side. Positive this one got short. So if I attach a wire to that solder point there, that cap, that's our positive. I just need to find a ground. Again, that's going to be super easy because very likely the other side of this cap here is going to be a ground. It'd be interesting just to measure some of these here. Yeah, that's a ground, I think. We might even find that some of these measure as the connections to these, actually. So if I just check the 5 volts again, you never know. Might have been designed to have a 5 volt input there. No, it hasn't. But nevertheless, I think we've got a ground. Yeah, we've got a ground there on that second pin. I'm going to solder onto that because trying to solder onto these small components and things here is a pain. We could test over here. Yeah, that's a ground, look. Dead short. Dead short, 0, 0, 0. So I'm going to set the ground from there. That's the easiest thing. So you might not be able to see this, but just watch. You get a kind of flicker as I press the power switch. There, it's like a little change in light. Just watch, I'll do it again. There, kind of like just like a little flash. Isolating the board from the screen. Got the ground here, 5 volts coming in, and I've just checked that this wire definitely goes to pin 2, which it does, and we've got a steady 5 volts there. So all we need to do now is measure the current. So I think that's proven that we can use this PCB here, we can use the DC to DC converter here to, take the 5 volts from here to the Nomad PCB. So the Nomad's going to be powered by the DC to DC converter, and we just need to feed, connect obviously a ground wire up as well, and connect a wire for the 9/12. And I say /12 because if you measure the output of a Mega Drive power supply, it varies. It's probably some of them it goes up to like 13 or 14 volts. So it varies between about 9 and about 13 or 14 volts, but this will be fine. It accepts inputs up to 40 volts, this DC converter here, and they're super efficient. They don't get hot or anything. So I've removed the PCB from here again. I think the next thing we need to do is remove the screen here, this. So we'll just see if we can just push that out. I don't know how easy this is going to come out here, actually. And of course the way to do this might be to heat from the other side, but there you go, you can see I've done it. Push that off. Yeah, we've lost one of the buttons in the process here that will wobbled out. I'll probably, before I start to reassemble it, I'll remove all the bits of glue around there before we put the new screen protector on. It's not too bad that really, I mean it only had a few small marks on it, but I understand the one he sent me is a glass one, I think he said, so that's super exciting as well actually, to have a really decent quality glass one on there. It's worth just cleaning on the inside of there because you don't want bits of dust and stuff floating around, so I'll do that as well. But right now I think the next thing we need to do is try and mount the screen in here. So the next thing to understand is where this goes actually, because I'm not really seeing how it stays in place. I mean, you've got the holes here that hold, you pilot some little holes there and the screws go through and hold that, so it will be held in exactly the right position, but I'm just not sure if is there anything in here to stop that moving around, and how do you know which way around to put that? I guess you've got to use the PCB to do this part. These little notches here are going to correspond with these holes, so you can only get it one way. I think that's the wrong way actually. Yeah, it is. It must be this way. So yeah, I think so. Yeah, because you can see, I don't know if you can about see that. Solid white, solid white, solid white, solid white. So I need to pilot some screw holes there, I think. I think the screen's going to go this way up. Let's just carefully move that. out of the way there. Yeah, it clips around the screen there, I think. Oh, let's move that out of the way. Yeah, it's a bit tight, that, actually. I just need a bit of a file down or something. Oh no, that fits. It snugly holds that. Can you see that? So it holds the screen there super well. He's done a really good job of that. That's perfect, actually. Absolutely perfect. And then he's got a little area here for the PCB. Bear in mind, you know, the underside of here, you've got some connectivity points there, so you want to get a bit of Captain tape just over these here, actually, and those. So, you know, the corner things there are ground, so they're okay. And then it's held in place like that. I think what I would do is perhaps use a double-sided sticky pad. I might just do that, actually, and that will isolate the underneath and hold that in place there. And then the final thing is just to kind of, I don't know, just maybe stick a piece of tape or something over there to hold those down. He's already put a piece of Captain tape over here, I think, or someone has. I'm guessing Dennis did that for me to make sure that nothing shorts there, and then that can just mount onto the underside of that PCB. So I think the next thing I'm going to do actually is just pilot some holes in the centre of these here. So I've got a drill bit here, you can see it's not quite as thick as it needs to be. It could do with being a little bit bigger, actually, you know, because that's the screw and that's the hole I'm going to drill. So it's about right. I'm going to give that a go. So let's just put that screw down, and we'll get this into the drill here. I hope it'll fit with this because it's designed for some really super small bits. This, yeah, there we go. Should work. And this is one of these ones where you just push you hold the thing like that and push it, and it drills. So we're just going to carefully. I'll see if we can do this. I'll see if we can do the first one on camera here. We're just going to try and get it as centre as possible, and then just hold it and do a bit of that. Yeah, you can see that's very central there. No issues at all. I'll just go a little bit deeper, I think. It probably doesn't matter if you go all the way through, to be fair, because there's nothing on the other side. You know, you're not going to see the other side. You've got to be careful not to press too hard when you've got really thin drill bits like this, because they can break super easy. So after a broken drill bit and a broken meter probe, I had to change my probe. I made the mistake of going, oh hang on, let's just try and widen it a bit by pushing one of these through. And I pushed it in, it got stuck, and I pulled it, and the wire came from out of the inside of here, and the metal probe was still stuck in there. So yeah, I mean, luckily I've got a few spare sets of these. Done diagonally opposite here, and I'm just going to leave it like that for now and see how it mounts. The reason being is because we don't know whether it's going to be ever so slightly off. You know, that hole might not be very straight, this one might not be. I've got no idea. We can always pilot and drill these ones later if it's perfect. If it's not, it means they can then use these ones instead and try and get the alignment perfect. I mean, he has sent me 2 of these, and I think that's why. So yeah, we'll just go with that now. I'm going to mount the screen and stuff and attach it to the PCB, and we'll just see how it looks. So I've got some double-sided pads there, just because it's going to make it super easy to mount it, and it's not going to interfere with the, you know, you're covering the connections underneath there. So yeah, it should just make it nice and easy. They're probably not cut perfectly straight, these, and they're not going to be exactly the same size. But we just need something just to help us mount that. So if we now carefully flip that over, it clips onto the screen really well, this plastic mount here, and we'll just get it in there and push it down like that. There we go, all done. So there's our little module. And thinking about this now, I'd have been better off doing the soldering before I put it in here, because as you can see, I'm going to have next to no clearance there to solder. So just trial fitting it with the 2 screws in place. You can see, if you look at this rectangle here from the screen protector, can you see that looks totally perpendicular with the, I mean, it might be a 1/4 of a degree or 1/2 a degree off, but it kind of looks squarish in the corner there, so I think that's pretty straight actually. So I think that should be okay. So I thought about this, and the best way of wiring this is take the 5 volts, and I've took it from, I think it's a little cap there, this side of this cap here. It's easier than trying to get on the very edge there and having the wire trapped. So that's my 5 volts, a nice good connection. And then I've put the original connect cable that comes with this, on the other end here, if I can find the end of it. You've got these here, so, I've measured, the centre point there is obviously the 12 volts, the ground's on the outside. You've got grounds on the outside of these. I'm not entirely sure what the white one's for, but this is the composite video, the centre point there is composite video. So we can use the connector here for the, 9 to 12 volts roughly, somewhere in that region, which I think is the red. The black is the ground and the yellow is the composite, and I can just trim it down, remove the black sheathing here and just route them to wherever they need to go. The idea being you can just detach it here. You've only got that one solder point then for the 5 volts that's going back to the Nomad that most people wouldn't have, but in my case I haven't got a regulator, so I think it's going to make it more efficient, so this is what I'm going to go with. So we've got it mounted there, and you can see now this is going to be a lot easier to route these wires. The composite will take from the pin here, one of the pins here on the AV connector. That's where the composite's going to be, and then we can route the ground +5 +12 over here. I just need to work out the best place to take those from. So the cap that I would replaced here, the one that had gone next to the regulator, the positive side, the +5 is here, and I know that because I measured that to the inductor here. There's a short between this inductor and that cap, that position there. So our 5 volts is coming in from the DC to DC converter there. The 12 volts, or just 9 volts, I must stop saying 12 volts, comes from the centre pin of the 3 pins of the connector here. The ground comes from that side. The one thing I need to check is just make sure when this is switched on and off that the grounds are not affected there. I can't imagine that would be the case. And it's a similar thing with the battery bay. We haven't done anything with the battery contacts here, so I'm not sure how those are wired. I can check that in a minute perhaps before we assemble this. But the final thing now is to just route the composite wire over here. So I'm just going to look at the pin out for this port here and just work out which one of these pins is the composite signal. So looking at this diagram here, pin 4 comp video, and I shouldn't have tapped that, I hate it when that happens. Yeah, pin 4, so we can see on the row with 4 pins it's that pin there. I think this is viewed from the back. Well, you can tell because the orientation of these, if you look at the back of the socket there, if you've got it looking like that with the 2 pins on their own with a gap and then one there, you're looking at it the same orientation. And then I can just literally stick one of the probes into the port and then just measure around the pins there. And I'll see if I can show you this. We'll just test continuity first. Yeah, so we've got it in there. You need pretty thin probes to do this, and we can just tilt it over and just measure the connections here. One there, is it? Yeah, so on that bottom row, not the first one, not the second one, but the third one is the composite. Let's just check that again. Yeah, that's right. Oh, hang on, we've got 2 there. That's interesting, it's joined to 2 of the pins there. I'm guessing it's acting as a sync as well. Quick correction there, it doesn't join to the 3rd pin, it joins to the 4th pin, and the 4th pin goes to this test pad. So it's easier just to solder that test pad, I think, actually. I must have been shorting across the contacts there with the probe when I was measuring. And there we go, all wires joined up. So, you can just tuck these slightly out of the way. Bear in mind, we haven't got the inverter module. This didn't come with the inverter, as Dennis told me right at the start here in his letter. Obviously, like I said, we'll revisit this because there's a few caps that I would want to swap out moving forward, but at the moment, as you've seen, it behaved really well with the TV there, it worked perfectly. So just for now, I think we can try and reassemble this and give it a try, see what's actually happening with it. I checked everything before I wired it up there, and you know what, I'm glad I did. The connection over here, where I had the +5, that's wrong. It needs to be over here, so yeah, that was nearly a fatal mistake. And if I switch it on, you can see we've got produced by or under license by Sega. That's looking sweet. Now that's just with 5 volts coming straight in. So this shows that you don't even need anything going into the regulator there on the the DC to DC converter on the LCD module. You can just feed 5 volts in. So I'm guessing if the battery terminals were wired to take 5 volts straight through to the board, it would still work. The screen would still work here. But that looks absolutely amazing. It really does. Bear in mind, I've still got the screen protector on at the moment. Sweet. We've got no sound because I've not got the speaker connected. But I think I've pulled it off. I think we've done it. mission complete. So I just need to just carefully reassemble it now and test it with the DC power jack. Actually, I might just go and try it with the power jack actually in an exposed state like this, just to make sure it's working okay when you feed something in up here. As you can see, that's working from the DC power jack there. Sweet. Now there's another problem. Because we're taking the 12 straight from the jack, it's not switched. So I need to just carefully move the positive here to wherever it comes out of the switch actually. So it took me a second or two to work out what the hell's going on here, because I was like, okay, well this must go to the switch, and there's no join, and I thought, well, there's a diode here. I thought that was reverse polarity protection. I think it is, but the way you've used it is in series with the input, so you know that's another source of failure on these as well. So the plus 12, 9, 12, whatever it is, you know, the DC input here goes into the anode of that diode there. So you've got, you know, a 0.7 volt drop across that. So from the cathode side here, and this is where your reverse polarity comes in, because if you've got the polarity connected the wrong way, because of this diode here, you won't get a full circuit. And it goes across to the left-hand pin of the switch. So, yeah, so we know it's coming into the left. So what we can do is just test on continuity from left to middle. Yeah, we've got a switch short there, so that's on. Switch it off. There we go. So the middle rail then comes out of here, and this is what I want to trace, because really you're better off taking it from where there's a position of a cap, actually. And I'm guessing one of these caps, I'm not sure where. I would have expected there to be a cap on that side somewhere. And yet another correction. Because the switch was on, when I was measuring from the cathode here, we had a short on the end pin. Well, actually it goes to the middle pin. So the end pin is where, presumably when it's on, yeah, then you get a join. So we need to connect to the left-hand pin there. So I'm guessing that will go to a cap somewhere, perhaps. Yeah, there we go. Yeah, it's the cap. Now this is the through-hole cap that I haven't replaced. So you know what? I'm going to replace that now. Because these, the two caps here, the one that's on the 5-volt side, the one that's on the 9/12-volt side, this one, they're super important. You really don't want crusty caps there at all. So despite this working as is with the caps as they are, I may as well swap out that through-hole cap now and not regret it later. So the easy way to remove that was just to heat each leg from one at a time on the other side and just pull it through, you know, and then it's come off. Unblock the holes just using my cheap desolder pump. I mean, I could have used the desolder station, but you know what? It's not worth powering it up for something just like that one cap. And then we can just get the replacement cap there. It's 100 microfarads. It seems a bit low to me, actually. I think if I didn't have a kit, I'd be perhaps uprating that a little bit. But it's going to be designed in such a way, you know, because of the regulator here. I think you need a smaller size on the output side, but then again, isn't that one on the output side 820? So it's got quite a beefy capacitor on the output side. But then again, the current draw is going to be pretty high, so that cap's not going to hold the charge for too long. So yeah, someone's probably calculated exactly the right size of cap there. Nevertheless, we'll stick that in. It's the right one, it's the right size. Just need to just carefully solder the connections on here. And then once we've done this, we can attach that wire and clean up. I will clean up this area because, you know, you can see it looks a mess. There's tons of flux on here. It's an awful mess, this area. Mainly because I've been soldering. You know, the board was clean at the end of the previous video around this area here. Try not to get too near that little cap there because we could have created a short. Leave it long enough to flow through to the other side. And then just trim the legs off there and clean up. I'll probably go over this with a bit of IPA and a toothbrush actually. I'll go over with the cotton bud first. There we go. So as I start to reassemble this, make sure that's totally straight, that piece of shielding. Bend this prong up a little bit because that makes a contact with this position here, I think. I've moved these little components just across a little bit just so that that's visible there, you know, it can make a connection with that. Make sure your prongs are totally straight and then, you know, start to get that back into position here. Obviously it'll clip back in there. Make sure the contacts come out here. You could clean those with a fiberglass pen if you've got a bad connection there. But before we get this in, I may as well clean all of the exposed bit, you know, the bit you see from the outside here, with some soap and water. You know, that's all I've got on here is a bit of soap and water. Just clean the flap up just so it looks nice and tidy, because otherwise it'll just mean dismantling again afterwards. You know, you can clean all the bits of dust and dirt out of there. And then I think the shielding goes over. Again, just make sure this piece of shielding is straight and you've not got any bits bent, etc. See, like that probe there's bent. When I had this assembled before, it wouldn't power up, and I think that might have been shorting something out, actually. Yeah, I suspect that's what it was. So yeah, very carefully inspect that before you, let's say, start to slide this all back into place. I think it should sort of clip. Yeah, there you go, like that. And then you've got obviously these connections here. So make sure those are okay. Yeah, they are. You want to make sure that all the cart pins here are not shorted out by anything as well, but I think we're okay. Those are standing off, I think. And then the door should just literally, you know, slide into place here like that. We can get the screws here and all the smaller screws there. Take two. There's me thinking, oh, it doesn't matter which order I connect the ribbons, you know, I can connect the ribbon up afterwards. You can't. Once this is inside there, you can't get access to that. So, yeah. I'll just disconnect the ribbon from here again, and this one's really annoying actually because that piece of copper underneath gets in the way when you're trying to put it back in. It kind of folds up. Can you see that? It's not staying stuck down. Anyway, so the other side here we will stick into here, and yeah, it goes. It can only go one way. You have it with the blue side facing up like that. Just carefully try and push that in. I'm not sure if that's in or not, actually. Yeah, I think it is. You see that? You just see a little bit exposed there from the other side. Try again. So, reassembled that bit, cleaned all around the flap there, but can you see you get dirt on the edges here? This is another reason to try and wash the whole thing in the sink, but yeah, you can get that off with some soap and water here, like this. Look how dirty that is. Use a toothbrush, some soap and water and a toothbrush on these indented bits here, and that cleans those up. So I might as well clean this up now, because there's no point in you know, sticking the screen in here when it's super dirty. And again, you could wash this in the sink, but I'm going to try and go over all the internals of this with you know, a paper towel and some soap and water, and I'll use cotton buds as well to get into the little nooks and crannies, and we'll just get it nice and super clean. You get a lot of dirt in the cavities here, can you see this? So, you know, sometimes the best way to do that is, you know, with a soapy rag like this, just do a bit of this, and you can get right in there. Look at that. I think the mode, it relates to the 6-button thing here. It's a bit like you get on the 6-button controllers. But yeah, we can clean over that. You know, any of these indented bits, again, just get a little bit of soap and water and a toothbrush at different angles here, and you can get any of the dirt out of the embossed bits here, you know. So I'll use some IPA on there in a minute to get this glue off. Teaspoons are the best way to remove these because the pressure fitted onto the thing below. You can just carefully, you've got to just get a little bit on one side, a little bit on the other. Easier said than done. And you can kind of prise them out. Just try it with one. There you go, it's come off. You can see that without doing any damage to it, and look at that there, it's filthy. So we can just clean that up now. So we're getting there. Most of the dirt has been cleaned out, well, all the dirt has been cleaned out of that, so we'll just remove the screw holding that PCB in there. And as I say, you can just clean the contacts up on that and clean those and refit it. So then ideally you want to use a little bit of IPA on the edge here where the glue was, you know, to hold the old protector on. Try not to go on the outside, you know, stay away from any printed stuff like that there. But we just want to get the thing as clean as possible there before we fit the screen protector. So as you can see, that's all clean now. Now I'm not sticking this in, I'm just putting it there, and it holds itself in place because of the sort of stickiness of that. And we can, you know, pull that back off and stick it back on later. It's just going to stop dust going inside here. We just need to just clean with cotton buds a little bit more in here, but that's almost done now. Again, the sink is the best bet, but you know what, with some soap and water and a brush like this, I can get this looking super new, I'm sure. So I'm just about to mount this in there. See the screen protector here? The cover has just come off, so this is going to be a blooming pain. Somehow I've got to try and find where the edge is and try and lift it up without damaging the screen. And the way I manage that is by moving it from here, sticking it over there, and that side it's managing to grab it. So I'm going to pull that in a sec, but what I want to do now is just make sure that I'm kind of holding this in place here. Blow out any dust, make sure you've got no dust in there whatsoever, and just be ready to fit it, you know, straight in here as you've removed that. You know, you can see bits of dust and stuff landing on there already, so yeah, just make sure everything's super clean. Let's just work out which way this is going to go. It's going to go that way, I think, isn't it? Yeah, it's going to go that way. So we'll just carefully just peel this off. Try and hold it that angle so that dust doesn't settle on it. Stick that somewhere where we can reuse that protector and just get it into position, I think. Yeah, I need to watch some of the wires here. See the yellow wire? Here, it's just kind of crimped a little bit there. That's it. And I think we'll get the screws back in place now. Watch you don't trap that. I had that trapped. I had to just lift it up a bit, pull the wire out and then put it back down, and then clip, you know, your start select, speaker. 3 or 4 screws hold the PCB in. Now bear in mind I've not put the 2 screws here. That's just in case I need to adjust the screen, because we don't know whether it's going to be totally straight. But the final thing now is to, I've got to be careful, because obviously I've not got the screen protector properly attached. Yeah, slide this in. There we go, it's gone in. So make sure it's totally in and then just pull the housing back. There we go, that's it. So I think we can now just carefully, well hopefully, I'm not really sure how that sits inside there because it feels like it's going to get trapped, I don't know. And obviously make sure you get your power switch. Now I've used the Game Gear one. This was what Dennis suggested I use. Yeah, I'm not sure it's together right because it doesn't feel very firm around the edges. I don't know. Yeah, I think that's it. I think we just need some screws now. Although it kind of feels a bit. No, that's right. Yeah, that's right. It just looks a bit weird here. See that? I think that, but that's normal. I think, as far as I can see. Now this is the hard bit. I peeled this off, made sure there was no dust on the screen, but as I put it back in, it's aligned left and right, but it's kind of sat here. So I need to try and peel it back off again without damaging the blooming thing. So I think what I'm going to have to do is use the spudger, try and leave the plastic bit on it just to protect it if I can, and just try and see if I can lift it back out. I'm going to damage this, I think. It's probably easier if you peeled this off and stuck it on that way, but then you're not going to have the protection from that. Oh joy. There we go, got it back out. Hopefully not done any damage to it. But yeah, this is not easy. Make sure there's no dust in there. Start from this side, I think. Yeah, and then press it in. There we go. That's it. I think. Why have we got a white thing on here? What's that? Why has it still got a white cover? Oh, this is a nightmare. Well, I am a complete moron. I don't get everything right all the time. Because I hadn't even noticed that piece of, you know, paper. That I hate it when there's things like that. You pull one layer off, then there's another layer, then there's another layer. And that's exactly what happened. It was like, when you saw that white bit there a minute ago, you were probably screaming at the screen going, why have you left that on? I just didn't think I'd left it on. It was a silly thing. So then when I tried to prise it out very carefully, I haven't damaged the plastic here at all. But you can see it just shattered. I heard a crack, and there's just a little crack there because it's glass. Now I could replace that. I don't think I'm going to do. What I think I'm going to do is just cut a piece of black vinyl and just and stick it across the very edge there or something, or just in that corner maybe. I don't know, because the screen is perfect, as you can see. It looks perfect, and when I switch it on, the display is absolutely amazing. So yeah, I'm not too bothered about that. It's got a little mark here anyway, so you know, it's not the end of the world. Could replace the glass again, but it would be a bit of a waste. I reckon I'm just going to stick something small in that corner there, just to obscure that, a piece of black vinyl just in the corner. Anyway, I need to find some screws now. This came with no screws. I'm hoping the Game Gear screws might fit this here as well, so we'll give that a try. So as you can see, I've just put a piece of shiny black vinyl there, just to remind myself of what a moron I am. And yeah, haste doesn't always help. I was so excited to get this thing working that, yeah, there was a little chip there. But anyway, we'll clean off some of these little scratches now with some plastic cleaner, but that's not bad, actually. I can live with that. It's just a reminder of, yeah, do things properly. Check things before you commit to sticking protectors down. So I've just been going over this gently with a little bit of plastics here. You see, like these marks here, you've got a white mark there. And I'm suspecting I can probably polish that off. That whole side's a little bit worn, actually. It's because it's had a lot of, you know, usage. You know, it's been held in hand there. Can you see? And it gets kind of like an ingrained dirt off. You might not get that white mark off. No, it's still there a little bit. Look, you can see. You press a little bit harder. Get a bit of black, back to black on a cloth, and just gently wipe over it with that, because dried out plastics can go white like that. Dried out plastics can go white like that. Actually, black ones particularly. Maybe got black plastic. You can see I've got some, got a bit of polish just in the gaps there, so I'll just brush that out. Yeah, that's not looking too bad now. So I think you'll agree, that's looking amazing. Even with my bodgy fix up there, that looks sweet. So let's go plug it in and I'll show you what it looks like. You can see a reflection from the camcorder there, but I think it's looking amazing actually. Sweet. Let me find the start button. Let's try and find the... Just adjust the volume. Yeah, that's maxed out. Turn it down. Let's start it. This is the colour enhanced version of Hyperstone Heist actually. So if you're familiar with this game, you might notice the colours look a bit more bright and vibrant and stuff anyway. But that looks amazing. And it's nice and straight, you know, and the way this is designed, it's kind of like a slant anyway, but if you look at the screen, it's totally square. I can see a nice square edge down that side. It's perhaps just a little bit off on that side, can you see that? But still, I think that's absolutely remarkable actually. I think Dennis has done a fantastic job with that screen mount there. Amazing stuff. I might just try my EverDrive in this now, because in theory that should work as well. I thought you had to mod the cartridge slots on these in order to fit PAL games, but that doesn't seem to be the case. And that Game Gear switch works perfectly there as a replacement too. So I've got the EverDrive in this time, and as you can see that's working as well. So yeah, I mean the display's not quite as good as like a modern RGB display, you know, when you use these composite screens here. You know, you can see it's just got that slight fuzziness you get with composite. But still, it gives a really good display, and I'm sure it's better than the original ones. Bit of Barbarian here. This is homebrew. It's a port, well there's multiple ports. You can play all different versions on the Mega Drive here. I'm playing the Amiga version at the moment. You can see that looks sweet. So a quick look at it here in a room that's quite dark, just so you can see how bright the display is. It's making the black look a lot whiter than it really is. It's blacker to the naked eye, but as you can see, that looks absolutely fantastic. Let's just start it. Had a good play on this yesterday for about 2 hours actually. No problems at all, perfect crystal clear display, and I had great fun playing this particular game actually. I got, I think, level 4. Got to the boss rush bit. I don't know how far I was off the end, but it was great fun nevertheless. I'll show you a couple more games as well. So a bit of Sonic the Hedgehog. Can't not show Sonic on a Mega Drive. So again, it's like you're seeing that black sort of fade into white there. I don't see that at all. To the naked eye, it just looks crystal clear, and the colours are really super vibrant. See, on the LCD I can see some outlines there, but on the screen I don't see that. It just looks absolutely amazing. One thing I would say is, I noticed on Turtles, the very, very top of the screen, it's off by just a little, tiny little bit. But you can see, you can see all the display there. And it's a similar thing with the bottom, it's just right to the bottom. Can you see that little blue line? I don't know if that's going to come out on the capture or not. There you go, you can see it now. So it goes right to the very bottom. And as you can see from the sidebars, yeah, wait for that to go. It's just super bright there, so it looks kind of weird on the capture. And again, like I say, I see a solid black, you see sort of a whitey sort of black, but yeah, it looks perfect to me. The one thing I would say, can you see that ripple? There's like a little ripple across it. Sometimes you see that on certain colours. Yeah, you can see it in the background a little bit there. So these parking screens, they're not perfect, the parking composite screen, they're not perfect, but they're blooming good. Way better than the original one would have been. Sweet. I don't think I've ever played the Mega Drive version of this, but I mean, it looks and plays seemingly just the same as the Amiga version. Yeah, so you can see what I mean about these lines. You get lines kind of like coming across the display here with these screens. One thought that did cross my mind is that the composite signal, I should use a shielded wire for that, because it's quite long across the board there, it probably won't make any difference, to be honest, with regards to that signal. The other thing is the banding could be coming from the DC to DC converter there, but it's so subtle, and in fact the thing is, you don't see it on the TV, so it's not like it's affecting the Mega Drive video output itself. It's just something on the LCD screen itself that. But nevertheless, I think it looks amazing. Ow. So as per the previous video, massive thanks to Dennis. I have enjoyed working on this so much last weekend and in the evenings and stuff, and this weekend. And I played this an awful lot since I got it up and running. In the next video, we'll completely recap this. You can see I did swap out the screen protector there. Can you see that? It's no longer got the one with the chipped corner. That was eventful in its own right, as you'll see in the next video. And in the next video I'm going to do the mod to support Master System games as well, maybe one or two other things as well. I do hope you found the video interesting. Please like, share and subscribe, and I'll catch you in the next video.